In this video, we are going to talk about a second type of asymptote, the horizontal asymptote. Keep in mind that the equation of any horizontal line is always in the form y is equal to a constant. So the line y is equal to d, where d is a constant, is the horizontal asymptote of f of x if f of x approaches d as x approaches infinity or negative infinity. I'm going to draw 4 scenarios. The first scenario, the graph could be approaching the line y is equal to d when x approaches infinity and x approaches negative infinity, and both is happening above that horizontal line. Second scenario, where again the graph x is approaching negative infinity and x is approaching positive infinity as the function f of x is approaching that horizontal line y is equal to d. But this is all happening below the horizontal line. The third scenario, where x approaches negative infinity and on the other side x is approaching positive infinity, and in both cases the function itself is approaching the horizontal line, but this time one side is from below and the other side is from above the horizontal line. And of course, the last scenario is just the opposite direction. To find the horizontal asymptote, given f of x is equal to p of x over q of x, we do need to determine the leading term of the numerator and of the denominator. So the numerator here would have degree is equal to n, since it has the highest exponent being n, and the denominator should have the degree n. Then we have 3 scenarios. If n is less than m, then y equals 0, or the x-axis, is automatically the horizontal asymptote. If the degrees of the numerator and denominator are the same, then we'll take the leading coefficient of the numerator, divide by the leading coefficient of the denominator, and y is equal to that quotient is the horizontal asymptote. And finally, if n is greater than m, then there should be no horizontal asymptote. A few things to note here. There can only be one horizontal asymptote. Unlike vertical asymptotes, there could be multiple. Second, the graph may cross a horizontal asymptote, which is different from the vertical asymptote, where the graph cannot cross a vertical asymptote at all. And to determine where it may cross the horizontal asymptote, we can let f of x be d, given y is equal to d is the horizontal asymptote. So let's look at some examples. Find the horizontal asymptote, if any, then determine if or where the graph crosses the horizontal asymptote. So let's determine the leading term for the numerator. So leading term here is 8x squared. Leading term for the denominator is x to the 4th power. So the degree for the numerator is 2 and the degree for the denominator is 4. Since 2 is less than 4, we're looking at the first scenario. So therefore, y is equal to 0. It's automatically the horizontal asymptote. Now, to determine if the graph crosses the horizontal asymptote, we would let the function 8x squared plus 1 over x to the 4th plus 1 be 0. The only time that a fraction can be 0 is where the numerator is 0. So 8x squared plus 1 is equal to 0. We are going to solve by subtracting 1 from both sides, so that will give us 8x squared is equal to negative 1. And then divide both sides by 8 to isolate the square. So we have x squared is equal to negative 1 over 8. At this point, we would take the square root of both sides, but we can't take the square root of a negative real number, so therefore this one has no solution. And because it has no solution, it means that the horizontal asymptote will not cross the graph. So we're going to say will not cross here. Second example, the leading term for this one is 8x squared, that's the numerator, and leading term for the denominator is 2x squared. Degree of the numerator is 2 and degree of the denominator is also 2. This time, the degrees are equal to each other, so we are looking at scenario number 2. So in scenario number 2, when the degrees are the same, the horizontal asymptote y will equal the ratio of the leading term of the numerator divided by the leading term of the denominator. So we're looking at 8 divided by 2, and that will give us 4. So y equals 4 is the horizontal asymptote. Now we are going to see if the graph is going to cross this horizontal asymptote. To do that, we are going to let the function 8x squared plus 9x minus 5 over 2x squared plus 1 equal 4. I'm going to put 4 as 4 over 1, and then I'm going to do cross multiplication. So this will give us 8x squared plus 9x minus 5, and that is equal to, cross multiply here, we get 4 times 2x squared plus 1. Simplify the right side of the equation. I get 8x squared plus 4. I can see that 8x squared cancel on both sides, so I'm left with 9x minus 5 is equal to 4. Add 5 to both sides. I should get 9 over here, and then divide both sides by 9. I get x is equal to 1. So what this means is the graph will cross the graph of h of x will cross the horizontal asymptote, which is the line y is equal to 4, at the point where the x coordinate is 1, which is what we calculated, and the y coordinate would be 4, which is what we found here. Third example, the leading term of the numerator is 2x cubed, leading term of the denominator is x squared. Looks like the degree of the numerator is 3 and the degree of the denominator is 2. Given that the degree of the numerator is greater than the degree of the denominator, this will fall into scenario 3, where there should be no horizontal asymptote in this case.